Welcome back. In the past few videos, we've been able to check the character's power level by looking in the details panel and basically watching that character power value increase or decrease as the game mode decreases it or as batteries are collected. To make that change a little bit easier to see and also give some gameplay feel, we're going to do some visual effects and also change the character's speed as his power changes. So we need to go to the character class, which is here in the code, and we're going to create some properties for basically the character speed's dependence on his power level. So those are going to be protected. We can put them here underneath our initial power, which is also a protected variable that we were working on with power. We're going to have a float called speed factor, and also one for base speed. And this is going to be much like initial power in that it's going to be edit anywhere and blueprint read write and in the power category. But one thing that I did notice is that I wanted to make these also have that meta for blueprint protected so that, say, our game mode blueprint can't reach in and change either initial power or speed factor or base speed. So I'll just go ahead and add that to all three of these. So they're not only protected in the C++ sense, but they're also protected in blueprints as well. And we'll just copy that line and add it to all three of these. And again, we'll just make a little note for our future selves that this is the multiplier for our character speed. And this is the speed when the character's power level is 0. So when we come back, we have a little bit more of explanation for what those two are. Now that we have them, we can set baseline values for them in our constructor, which is up here at the top of our character source file. We can do that right underneath setting the initial power there. And just like that initial power of 2000 was something that I just came across during testing. These are for setting the dependence of the speed on the power level. These are just variables or values that I happen to like the feel of once I was testing the game out, but you could definitely try different ones. Just see which you prefer. Base speed maybe being 20 rather than the 10 I'm going to set it to, so that no matter what, he always has a certain baseline speed. Now that those are set, we can actually start manipulating the character speed based on the character power. And we're going to do that in the update power function we wrote down here. That's because update power is called every single time. It's basically called whenever power is increased or decreased. So by putting our speed change in here, our speed will also change every time the power is increased or decreased. We're going to get the character movement component using the getCharacter movement function here. And this is something that's included on all characters. So because our battery collector character inherits from the base class of character, it's got that movement component that allows it to run and jump and do all of sort of that bipedal movement that's already set up. And it's got a variable in it called max walk speed, and that's what we want to change. And that's just going to be our base speed, because we said base speed was what happens when the power level is 0, and then we're going to add speed factor multiplied by the character's power. So first we change the speed, first we change the power, and then after that we change speed based on power. So it's important that you have those in this order, otherwise we'll be setting the character movement to be based on the previous speed, which wouldn't give the effect that we want. The other thing we're going to do is a material change. And we're going to actually set that up in blueprints because it's a little bit more straightforward that way. However, we do want to know that it always gets called again every time update power is called, and we're going to do that with the blueprint implementable event. The blueprint implementable event, we're going to make it here be protected. We'll do it right below speed factor and base speed, and it's going to be called power change effect. and it's a U function. And yes, this blueprint implementable event keyword means that we don't have to define the function in code at all. We just call it and let the blueprints worry about the behavior that's going to be attached to that event. So we just say call visual effect and power change effect, and everything else is left up to the person creating the blueprint. I don't have to worry about if it's going to change material or summon a particle effect or some combination thereof. I just say, at this point, I want there to be some visual effect based on his new power. So we'll go and compile that, and we can start wiring up that blueprint. Now our character, because we're using the template, if we open this up, we can see that the mesh already has a material on it here. This element 0 has a parameter in it, this body color. So we don't have to set up any parameters. We're just going to work on accessing body color and changing it based on the character's power level. So that part is already done for you. If you're using a different character, or you want to add a different parameter to your material to drive, it's the same principle. I just want you to see that this is already set up as part of the template mannequin. So back here in third person character, and we did have to open the full blueprint editor in order to see these graphs. So if you're in the one that just looks like the details panel, make sure you click the open full blueprint editor link at the top. And we need to start in the construction script because we're going to make a dynamic material instance so that we can manipulate that material as the gameplay is going on. So here in the components on the left side, you can grab mesh and drag it into the graph. From that, we're going to get the materials. Now, I remember showing you guys that here under the mesh, there were 2 materials, and we just care about the first one. We don't really want to do anything with the logo at this point. So we're going to get, and that's just a typical array get, and the index is already set to 0. Now from that, we need to create a dynamic material instance. And it looks like that automatically connected to world context object, but we don't actually want that connected there. We just want that to the parent of the create dynamic material instance. And in fact, from here, the world context, we just want to add a reference to self because that's our world context. We are in our own worlds here. We can connect the construction script to the input of the dynamic material pin, and then right-click on that return value and promote it to a variable. We're going to call this our power material. And that just means we can access this variable later on during gameplay. So that's all the setup that we need to do to create the material. Now, if you need to learn more about dynamic materials or just some general blueprints, definitely check out the quick starts and material how-tos on those. And we're going to now go to the event graph, and we have that blueprint implementable event that I set up called power change effect. So it's just right there in the context menu. And we're going to get our power material that we just created and look for the vector parameter, which, just to refresh our memories, we'll go back to our material, which we still have open, and see that that's called body color. So go ahead and type that in here. And every time power change effect is called, we want it to set the new vector parameter value. So let's just connect that. But we do need to decide what the value of that parameter should be. And we're going to do that by looking at the current power level and comparing it to the initial power level and seeing if it's higher or lower. So we can get the power level and the initial power level right here in the blueprint because we've already set up those blueprint pure nodes, but also because we're within the character blueprint. So we're going to get current power, then we're going to get initial power, and we're going to divide the current power by the initial power. And that's just so that we can kind of get an idea if our power is more than we started with, less than we started with, and then use that. We're also going to clamp this between 0 and 1 so that if our power ends up being much higher than what we started with, it's not going to drive the color really crazy in one direction. Let's go ahead and clamp this, and 0 and 1 are already set up here. Let's move this down a little bit, and now we're going to lerp between two colors based on that comparison of the power level to the initial power. And there's a lerp for linear color, and we're going to put in that clamped value for our alpha, and then this for the return. And let's pick two colors that are pretty easy to distinguish. We'll say maybe like a teal color when the power is low, and we'll do sort of a almost that battery yellow or orange when the power is high. Let's do something more like that. Okay. So compile and save, and let's test this out. So we're gonna go, whoop. I think I didn't quite apply that material correctly, just 1 second. Actually, let's just do this for getting the material. So create dynamic material instance. We're just going to connect that right to the mesh and then put 0 on that. That way it gets applied all in one fell swoop. So we can connect this to our power material, connect this in line with our execution pins, and then we'll plug this get 0 result to the source material there. So we're still getting that first index, but now we're actually applying it directly to the mesh so that that will be ready to go. So let's go test that out now. So now I'm sort of a light yellow color because I have a fairly high power level, but if I wait for a moment, it will move down and should start getting more of a gray. I should be also getting a little bit slower. But then if I collect more batteries, I'll go back to a yellow. So you can see the effect. If I sat here and waited longer, you'd go all the way through the sort of the yellow to the gray to the blue, but just wanted to show you that both the speed and the power change are working now, and we're running around very quickly because I've collected a number of batteries. So in the next video, we'll actually do some more visual effects, this time with batteries and some lightning. Thanks!